Hi, cool coders. Today we're going to be looking at how to do error handling in Python. Now, this is a very important concept in Python, so I want to keep this succinct as possible so you don't get lost in the weeds on it. So let's dive in and take a look at how to do this, and then we'll talk about when and where to use this in our code as well. So we're talking about error handling today, but more specifically, when we're talking about exceptions in code. Now, an exception is typically something that your program can't handle. That's typically because it comes from the outside the scope of what your program is really trying to do. Now, typically in our code, we want to be able to create logic that handles user input to prevent them from entering bad data. So with that, we don't really need what we're talking about today in terms of error handling. We looked at an example of this when we looked at functions where we built a function that would only allow us to enter in numeric data. That's one type of control that we can use to prevent bad data. And that's actually a really good practice to do. What we're talking about today is more specifically around those things that are outside the scope of our program. And these are called exceptions. And an exception is typically something like something that your program can't access that is typically handled by some other part of a computer, such as disk access or network access. Suppose I wanted to go download something off the internet with my code. Well, in that call, I'm expecting that there is a reliable internet connection. However, if you've been on a computer at some point in your life, you've probably been disconnected from the internet and you haven't been able to access some data on the internet because of that. And when your program tries to reach out to that data and it can't pull it back, that's when an exception will happen. It will try to reach out to that data, grab it, pull it back, but it doesn't happen. And so what the operating system does is it just says, I don't know what to do with this, and it returns an error message or an error back to your program. And that is something that you can't control, so you have to wrap up some kind of logic around that. And that's what we're specifically talking about today when we're talking about exceptions. And there's a myriad of different kinds of exceptions that can occur. So we kind of have to be smart when we start writing our code and be able to kind of guess or anticipate where these might happen. I can almost guarantee you that when you're dealing with any kind of IO, that is input output, that's something other than user data, that's like accessing files on a file system, that is accessing a network, that is expecting something to be available that's not like resources like memory or certain levels of CPU or some kind of hardware that is such as a camera or a microphone, and you try to access that and it's not available, then sometimes you'll get something back in your program, and that's generally going to be an exception. So we're going to look at that in detail today. Okay, let's talk about the block of code that will handle exceptions when they occur inside of your program. So this is called a try-catch in some languages. I typically call it a try-catch, but it's typically called a try or try-except in Python. I'm going to use the vernacular I'm familiar with, try-catch, because that's 90% of the languages call it that, but Python calls it try-except or something like that. It's basically a try block. So it starts off with try, as you might expect. And then this is where the code that you want to test or you want to handle the exception for is going to exist. So you would put some code in the try block that is potentially going to generate an exception. And then the next thing you have is an except block. Now, the except block is where an exception will be handled. And this is the place that you want to be aware of the actual error. And we'll look at how to get the error message back when we actually do an implementation of this. But first you need to do a try, and then you have the except that's going to receive an exception should one happen. Doesn't mean that one will happen. It just is in the case that it does happen. So if there is an exception raised in the try block, then you will go into the except block. However, if there is no exception, you can go into an else block like we saw with if-else statements inside of our if-else blocks when we were looking at those. And like if-else blocks, this one is a optional block. You don't have to put this in the code. The only two that are required are try and except, because those are the two that are going to be handling the actual code that you want to try against, and then the actual exception should one happen. Else is for when there is no exception. So this code will actually fire when there is no exception that is called. And then you have the finally block. Now this one is too optional. It's not used often, but it will be called anytime an exception happens, or if an exception doesn't happen. It's just basically a cleanup type of code that you might have. And this is one where you might use something to close out file handles or other things like that. not used, but it often, but it is used sometimes. I haven't used it much in my Python program, but you often will see try and except, because those are the two that are going to be handling all your exceptions in Python. So let's go look at one other concept first, and then we'll go over to Tony and look at an example of this. It's a fairly straightforward concept, but like I said, it's very important to get your head around this because you'll see it and use it a lot in Python and other languages for that matter. So the anatomy of an exception looks kind of like this. We have the raise keyword. Now this is used when you want to create your own custom exceptions rather than just the default ones that come with the system or whatever the built-in exceptions that you might have in Python. You would have a raise keyword. And then after that, you would have exception. And then inside of the parentheses, you would have an error message. It's important to include a meaningful error inside of your exception. The reason why is so that whenever somebody is debugging your code or you're wanting to display something back to the user, you want to have a meaningful message here other than just say like, oh, an error happened. That doesn't really tell anybody anything. But if you have an exception that has a meaningful error message in it, it will help better understand what's going on in the program. And that way somebody just doesn't write it off as, oh, it's a buggy program. You could say, oh, a network exception occurred, or file not found, or something like that. Then somebody knows it's not a problem with your program, it's something outside the environment of your program. Or you could use it for displaying the fact that somebody put in bad data. It's less than 0 if you're expecting a positive number, or it's greater than 1,000 if you're expecting something less than 1,000, or something along those lines. You can display meaningful errors in that context. So it's important to do that. It's kind of easy to get out of the habit of having meaningful errors, but in the end, it will help your code be more understandable and your program to seem less buggy if you have meaningful exceptions, even though they might happen in your code. Okay, I'm here inside of Tony, and I want to create an example that's easy to follow. So I'm going to start off with a function here. So I'm going to start off by add positive numbers. And I'm going to say two parameters, A and B. And this is simply going to return A plus B. So I can easily call this with the print command. So I go print, add the numbers together, and then I go 2, 3. And I can also do this with negative numbers, -2, -2, and 3. So both of these will work in this current setup right here. So I'm going to add 2 and 3 and get 5 back, and I'm going to add -2 to 3 and get +1 back. Now, because this is for positive numbers, I need to do bounds checking on it because that's what I want this function to do. And this in its current state will allow me to use negative numbers, which I don't want it to do. So what I need to do then is do some bounds checking on my data that's coming into my function. So to do that, I'm going to do an if block here. I'm going to say if A is less than 0 or B is less than 0, and then as we've seen there already, you don't have to have parentheses if you don't want to with an if. And then I'm going to say raise, and I'm going to say exception, and then I'm going to give it an error message. So I'm going to say some kind of meaningful error message. So I'm going to say numbers must be positive, like that. And so that is a meaningful error message. So with that in mind, let's go ahead and run this and see what happens. So the first one ran fine. I got back 5, but notice I get all this red all over my screen because I tried to call this one, but I got into my if block here and it said raise exception. So every time we've been seeing all of this traceback commands on our screen where we see all this red, that's because we're running into exceptions in our code that aren't ones that we've made, and we're not handling those appropriately. So to handle those exceptions, we need to create some try except or try catch logic, as it's typically called in other programming languages. So in Python, this is pretty straightforward. So let's do a try block here. So I'm going to say try, and then I'm going to say try to this particular number right here, this particular operation. And then I'm going to have except. And then I'm going to say exception right here to tell it that I want to have an exception coming into this block as error. And then what I'm going to do then is print error. So if there is an exception here, what's assigned to error will be the actual error message. So I can print that back to the screen just like any other string. So the exception will come back from here if that does fail, and it will give me an error that I can print out here. This one will run fine. But just to show you that there is an else block that I can use, I can say print everything is good, and I'm good to go there. And that's the else if this doesn't happen here. So let's take this same code block here. I'm just going to erase this and change the value to -2 right here. So this one should print out the sum of 2 and 3. And because there's no exception here, it's not going to enter into this code block. Rather, it's going to come down here into this else, and it's going to print everything is good. This one, on the other hand, will come into our code block right here. It's going to try to add these negative numbers to this positive number, and then it's going to hit this exception block right here because it's getting an error back from the function up here. So let's run this and see what happens. Now, notice what happened here, that instead of a bunch of red on my screen, I got a nice message printed back. And that's because in this case, instead of having an unhandle exception right here, which is the case where I have an exception that doesn't have a try catch or try except around it to handle that, that's called an unhandle exception. I have a handled exception in the case right here with this particular block. So this is the kind of structure that you want to have to anticipate when things are going to happen in your code. So anytime you're expecting an exception to happen, that could be you're looking at the code that is being called by your function or your code, and it has some kind of error message that comes back that it might be expecting, then you might want to put a try catch around that or try except. In other cases, it's if you're doing any kind of IO, you're working with hardware, you're working with networking, you're working with file access. Anytime you're doing IO other than just some basic maybe keyboard operations like with input, you probably are going to want to use try exceptions around that too, because that is one of the most common common sources of exceptions in code. There are other ones, but I can guarantee you that if you don't do that in your code, at some point somebody's going to run your code and they're going to get some exception that isn't handled, and they're going to think your program's a bug. But if you can display a meaningful message back like this, and say file not found or network unavailable for those kinds of exceptions, then it's not a problem with the program, it's a problem with something else. So a problem with the camera, or a problem with the storage, or whatever it might be. So good error handling is a good part of any kind of programming. Now, I do want to make a mention of something here, and that is the way that we use exceptions in our code. Now, as a rule, it is always better to try to manage user input than to try and use exceptions to do that. In other words, like in our example that we saw inside of our function where we had keyboard input where we were allowing the user to input only numbers, that is a good example of where we would want to use we would want to manage the input rather than try and use exceptions for everything. So in that case, I can write code to manage the user's input. I can restrict the kind of data that they input, like only numeric data in that case. But the case where we have right here, this is something that I have a function, and this particular function is expecting input from any number of sources. So I'm not actually able to control the input in this function. I'm just saying I'm expecting numeric data. So in this case, I don't have any control over the input. I can outside of this function, but inside this function, I have no control over that. So in this case, I want to be able to tell the program that there's bad data in there. So this one, because I have no control over it, I cannot do any kind of controls over it like IO. I want to then use exceptions in this case, because this is a case where I have no control and therefore I need to do something if bad data comes in this case, exceptions. And so in this case, I'm going to say raise an exception for bad data. In this case, numbers less than 0, they must be positive. And I need to handle that in the code if the particular function or particular code block I'm calling does have the potential to have an exception. So this case, I'm handling it even though it never happens. And down here, I'm handling it even though I know it won't happen. So this is an example where I wanted to show you the reasons why you might want to use exceptions in your code, because there are places that you do use these. It's just mostly to handle exceptions that are outside of your control, but you want to be able to use good coding practices to control errors when you can, such as bounds checking or type checking, like we did whenever we were doing keyboard input and we only wanted user input to be numeric. So for the challenge this week, I want you to add error handling to the DICE program that we wrote in lesson 8. So if you don't have this or you didn't successfully implement it, you can go out to the Cool Enough to Code repository on GitHub. I have the code samples from all the lessons out there, so you can go out there and check those out, and also have solutions from previous lessons for the challenges if you want to look at those as well. Lots of code samples there. You can go out there and visit the repository and get my implementation of that DICE program. It's called dice.py under lesson 8. And once you have that, then you can add error handling to mine. If you want to use yours, that's fine too. I basically just want you to add error handling to it. So let's go look at mine in Tony, and then I will walk you through what I'm looking for. I'm not going to tell you how to do it, but I want you to figure that part out. But I want to show you where I want it inside of my implementation of the DICE program. To get the code sample, just go out to this URL that we had in the deck, github.com/thewindmill/ce2c, and then click on functions right here. And this will have the dice.py that I'm looking at. This is a solution for the challenge for that particular week. This is what I want you to add the actual error handling to. So let's go over to Tony and we'll do a deep dive into what I'm kind of looking for here. Okay, I'm here in Tony and I have my dice.py pulled up, and this is what I want you to add exception handling or error handling to. So if I run this, this is going to only allow me to enter the data that I have available. That's numeric data. But my function up here is allowing for me to enter in data that is for anything. I could enter string data. I could enter in numbers less than 0. I could enter in all kinds of stuff that doesn't make sense for a dice roll. I need to have controls around this. So I want you to enter, create a error handling routine or some kind of bounds checking for this data that's coming into my dice roll program. And I want you to then throw exceptions in the case that something doesn't happen, right? So if I entered in, say, -22 and then 5, it's going to give me some kind of data that doesn't always make sense right here. So enter in value for this. It's actually preventing me from entering less than 0 numbers right here. But at the same time, I want you to handle that up here. So because this is a function that is expecting me to be able to enter in good data, and I don't have any control of it in the function. So I want you to implement the code that will throw the exception. And then down here in this particular code down here, I want you to put some try catches around the places that we actually call the actual dice roll, not a get number, but in a dice roll, where we have the case where we're handling the exception as well, according to the example that we saw on the previous slide. So I basically just want you to take this code here, add some error handling up inside of the function here that will throw an exception. And then I want you to add the try except code here inside of this particular call, so that in the event that that code does get called and an exception does occur, it will handle it appropriately. So looking forward to seeing what you're going to do to implement this. You can use your code or my code, either one will work. I just want to see where you're doing tries, and I want to see where you're throwing exceptions and you're appropriately handling those in your code. So thanks for tuning in, and looking forward to see what you guys submit for challenges as always. If you like this content, please consider liking this video, then clicking on the subscribe button to subscribe to our channel, then clicking on the bell notification icon and selecting all so that you'll get notifications when new content becomes available on our channel. You can also click on the share icon and share this video to any of your social media platforms. Sharing this helps make it more widely available for those who might be interested in coding. Also, consider following us on Twitter so you can see updates on Twitter whenever new content becomes available, as well as other announcements related to Cool Enough to Code. You can also help us out by becoming a patron on our page by going to our Patreon page at patreon.com/coolenoughToCode and then clicking on Become a Patron, and there you can find out more information about how you can support our work with Cool Enough to Code. And like always, you can check us out online at coolenoughToCode.com. There you can find a schedule of all of the upcoming lessons that we have. You can also find out more information and reach out to us online here. And you can also watch the live stream as it comes out each week on coolenoughToCode.com as well. And like always, thanks for watching this lesson on Cool Enough to Code.